Friends, welcome to my YouTube channel. Dhanesh here. In this video, I am going to discuss about some fundamental concepts in machine learning. That is, one is supervised machine learning, unsupervised machine learning, and reinforcement machine learning. Let's start. Just 1 second. We will close this. Fine. We will start now. Yeah. See, these concepts, it's a very fundamental. We will discuss in detail about these concepts and it's very useful. Let me talk about the what is artificial intelligence. See, in computer science, artificial intelligence, sometimes called machine intelligence, is intelligence demonstrated by machines. That's all that we call it as artificial intelligence, unlike the natural intelligence displayed by humans and animals. So that's different. Our human intelligence, it's different from artificial intelligence. It is the intelligence demonstrated by machines. Fine. These examples will give you a better idea about artificial intelligence. Examples for artificial intelligence are spam filters, smart email categorization, voice to text features, smart personal assistants such as Siri, Cortana, and Google Now, automated responders and online customer support, process automation, smart searches and relevance features, personalization as a service, product recommendations and purchase predictions, recommendations and content curation, personalization of news feeds. All these examples for artificial intelligence we are using in our day-to-day life now. You understood. Now, what is machine learning? Machine learning is an application of artificial intelligence, or it's a subset of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. That's machine learning. Examples for machine learning: medical diagnosis, statistical arbitrage, learning associations, recommendation engines, sorted, tagged, and categorized photos, self-driving cars, gamified learning and education, calculating customer lifetime value metrics, determining credit worthiness, speech recognition, and image recognition. All are examples for machine learning. Different types of C. We are going to discuss about the different types of machine learning. The machine learning, it is classified into three. One is supervised machine learning, second one unsupervised machine learning, and third one reinforcement machine learning. See, supervised machine learning. Let's first talk about supervised machine learning. Supervised learning, as the theme indicates, the presence of a supervisor. As a teacher, there is a supervisor is there for supervised machine learning. Basically, supervised learning is a learning in which we teach or train the machine using data which is well labeled. That means some data is already tagged with the correct answer. See, data is classified into labeled data and unlabeled data. Labeled data means, for example, you have some photos of animals. If it is labeled with this is horse, this is lion, this is tiger, then it is labeled data. If it is not labeled, it is known as unlabeled data. You understood. After that, the machine is provided with a new set of examples, that is unlabeled data, so that the supervised learning algorithm analyzes the training data set and produces a correct outcome from labeled data. So you understood what is supervised machine learning. Okay, so it is with the presence of a supervisor. Now, supervised machine learning, little bit if we are getting into the math, the majority of practical machine learning uses supervised machine learning. Around, we can tell around 80% of the machine learning applications currently we use are supervised machine learning. Supervised learning is where you have input variables and an output variable. So input variable, it is the independent variable, and the output variable, it is the dependent variable, and you can use an algorithm to learn the mapping function from input to the output. So this is y is equal to f of x. Here y is the output variable and x is the input variable. X is input, x is the input variable, and the output variable we call it as the it is the dependent variable, and input variable is the independent variable. Input variables we call it as features. In terms of machine learning, we can call it as features. The goal is to appropriate the mapping function so well that when you have the new input data, that you can predict the output variable y for that data. So the aim of the machine learning model is to predict the output. It is used for machine learning models are used for prediction. You know that. So it is from the machine learning model in supervised machine learning, it predicts the output, that is y, predicts y. Y means the output variable, or it is output variable. Y is known as output variable or target variable, all are same. Output variable or target variable or dependent variable, all these same, or dependent variable, all these are all same thing, it is y. X means it is the input variable, or you can call it as the feature. It is the feature. See, this equation I can write it as y is equal to mx plus c. This is the equation of a line, right? So this one I can write it as y is equal to m1 x1 plus m2 x2 plus etc. mn xn plus c. Here x1, x2, x3, xn are the features and y is the target variable or the output variable. You got it. So the goal is to appropriate the mapping function so well that when you have the new input data x, you can predict the output variable y for that data. That is known as the supervised machine learning. Different types of supervised machine learning. Supervised machine learning is classified into two categories of algorithm. One is the classification, second one is the regression. A classification problem is when the output variable is a category, such as red or blue, disease or no disease. That's a category. So variables or data variables are of two types. One is categorical variable, and you can call it as a continuous variables. See, regression means a regression problem is when the output variable is a real value, that is a continuous value. See, for example, height, weight, these are all real numbers. So such problems we address by using regression problems. So when we talk about the categorical variable, we will go for the classification problem. So whether the person is having disease or not, or whether the color is red or blue, those are all categorical variables. And you have continuous variables. Weight, it is a continuous, it can be 25 kg or 45 kg or 60 kg. It's a continuous data. Then you will go for regression problem. Fine. Examples are supervised machine learning. Some popular examples are given here. Linear regression for regression problems, random forest for classification and regression problems. Random forest is used for both classification and regression. Support vector machines for classification problems. Fine. Unsupervised machine learning. See, unsupervised machine learning is where you have only input data and no corresponding output variable. See, here you have x only input data, why is not there. The thing is, the goal for unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. The one important difference is unsupervised machine learning. It uses unlabeled data. So it has to learn the data in unsupervised learning. See, you understood what is labeled data. For example, a simple example, you have photos of animals. If it is marked like this is horse, this is lion, this is tiger, this is cat, this is dog, then it is labeled data. If it is not labeled, it is unlabeled data. So unsupervised machine learning, it is difficult to learn the unlabeled data. So unsupervised machine learning is used for unlabeled data. So there you have only input data, no corresponding output variable because it's not labeled. The goal for unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. Very important. Here we have to learn more. Then only we can come up with a solution because we are using unlabeled data. These are called unsupervised learning because unlike supervised learning, above there is no correct answers and there is no teacher. Algorithms are left to their own devices to discover and present interesting structure in the data. Because when we talk about the supervised machine learning, we give labeled data to train the data. For example, a simple example I can give you. The first hour we are giving the pictures of lion and tiger. So first the machine learning model is trained with labeled data of lion and tiger. So it is trained so the model knows lion and tiger. And after that, we give unlabeled data, and in supervised machine learning, the model can predict it because it is already trained with labeled data. When we talk about unsupervised machine learning, in the beginning itself, we are giving unlabeled data. So there is no supervision. We are not supervising. So there is no supervision for the, this model, this unsupervised machine learning. We are just giving unlabeled data, and it is the models, machine learning models, the algorithms responsibility to come up with the accurate solutions. So algorithms are left to their own devices to discover and present interesting structure in the data. Fine. Different types of unsupervised machine learning techniques we normally use are clustering. A clustering problem is where you want to discover the inherent groupings in the data, such as grouping customers by purchasing behavior. This is one good example you can understand. This is clustering. Association. An association rule learning problem is where you want to discover the rules that describe large portions of your data, such as people that buy X also turns to buy Y. That association rule. For example, a person who purchase shoes can also purchase socks, like that. So that association, so that is determined in this type of unsupervised machine learning. Fine. Examples of unsupervised machine learning. Some popular examples of unsupervised machine learning algorithms are k-means. It's a very important algorithm for clustering problems, and a priori algorithm for association. This is for association rule. Reinforcement learning. See, reinforcement learning is an area of machine learning concerned with how software agents, how your system, the software agents, ought to take actions in an environment in order to maximize the new notion of cumulative reward. Here you have different terms. One is the agent. You can think of it as a robot agent. It's this agent is in environment. So this, in this environment, how this agent is performing. If the agent is performing well, he is rewarded. If the agent is not, attaining their goals, it is penalized. Such type of learning is known as reinforcement learning. Reinforcement learning is one of the three basic machine learning paradigms alongside supervised and unsupervised learning. So here you have an agent, the environment, and if the agent is performing well, it is rewarded. If it is not attaining its goals, it is penalized. That is the concept of reinforcement learning. Practical applications of reinforcement learning can be RL can be used in robotics for industrial automation. RL can be used in machine learning and data processing. Reinforcement learning can be used to create training systems that provide custom instructions and materials according to the requirements of students. That's all about different types of machine learning. Thanks for watching. Please like, share, and subscribe. Thanks a lot.